The Mueller element is a general device described by a Mueller matrix. This allows changes in the degree of polarization of light, and it requires that the Stokes vector mode be used to enable partial polarization tracking. In this example, we have three planes. Polarized light is converted at the middle plane to unpolarized light. The bottom plane is a diffusing surface which interacts with the unpolarized light and reflects it back up through the system. The center plane does not interact with light which is going upward, so it does not interfere with the unpolarized light on its way up to the detector. So here we see the polarized light going through, becoming depolarized, although there's nothing we see to tell us that, but it has become depolarized. It then interacts with the diffuser, and the detector, the top plane, picks up that information. So we have started with polarized light, depolarized it, and then interacted with a diffuser. If we take a look in the Poincaré Sphere tool, we have the original source and we have the final state of light after interacting with the depolarizer and diffuser. So let's take a look at this. If we zoom in, we see a very tightly packed group of rays on the surface of the Poincaré tool near the left circular polarization area at the bottom. That's the source. It's fully polarized and needs to be depolarized to interact with the diffuser. So we did that, and if we eliminate the coordinate axes, we see all of the rays that have gone through the diffuser are actually concentrated at one point. So it appears that we only have a single point, but we actually have many. And these are fully depolarized rays. We can actually see that in a couple of ways. One is that the Stokes zero parameter is 1, but all the others are 0. But another way we can see that is by using the degree of polarization slider in the Poincaré Sphere tool, and if we take it all the way to 0, it has no effect on those rays. But the other rays, the original source rays on the Poincaré Sphere, have disappeared. So if we go up to 0.9, the original source rays are still missing. But if we go to a degree of polarization of 1, again, we can see the original source rays. So this shows that we can interact with diffusers with light that started out as polarized. And we can examine things like flux. If we had multiple wavelengths, we could actually see how different wavelengths interacted in the system. As a system-level advantage, this shows that we can use Mueller to set up a dividing plane between polarized and unpolarized parts of the system, and Mueller can also be used to enforce partial polarization in a system. The depolarizer does not have to be a complete depolarizer or a perfect or ideal depolarizer. It can also be a partial depolarizer, or indeed many other kinds of polarizing devices. Simple polarizers like linear or circular polarizers and some kinds of isolators can be described using a Mueller matrix.